So some of you might be, again and again seeing this PPT. So that's a basic hygiene that we do in every workshop. So please bear with us. I won't take more than 2 minutes. Okay. So to begin with, we are IoT NCR, and we started, India's large. We want to become India's largest open community for the development of Internet of Things. So we launched in December 2015, but we never thought that we'll become 5,000 members, this soon. So how we started it? So we actually wanted to learn IoT, Internet of Things, and we went in the market and to see what sort of trainings are available, what sort of things are happening, so that we can learn IoT. But unfortunately, none of us, was able to find anything that was really valuable and that would help us learn IoT. So we decided that let us start a community on our own and let us connect and collaborate. So that became our mantra. And now whenever you see an IoT NCR logo, you always see that there's a connect and collaborate written beneath it. So what do we do? So our focus is to connect with like-minded enthusiasts. So we do workshop, talks, open sessions. We do discussions, workshops, seminars, a lot of things. And we also are doing some open initiatives in which we are trying to build some products that come under open projects category. So far, this number has to be updated now. So yes, we have crossed 5,000 plus, 2 days back, and so far we have 150 and 150 students and teachers, and almost like 100 more people lined up, who are ready to get themselves developed on the IoT front. So we have been doing student development as well as faculty development programs as well. So we have been so far we have partnered with 6 major partners: IBM, Microsoft, Airtel, Aries, Nagaro, and SAP. And a lot of people have offered us locations across Delhi NCR. So they range from startups to co-working spaces and to corporate media houses. So these are the topics we have covered so far. So we have started. The very first event we did was the smart helmet for the motorcycle, and then to beacons, and then to IPv6 and the IBM Bluemix. And just to tell you, IBM Bluemix was the biggest event, the biggest meetup event we have conducted so far. So these are our partners. Some of these are corporate, some of these are startups, some of these are location, and some of these are media and conference partners. So they have been, their support has been, very elementary in our growth. So without the support of these people, we wouldn't have, reached this platform. So as I discussed, a few minutes back, so one of the programs that we run is faculty and student development program, and the objective of this program is to make the faculty aware about the latest and greatest happening in the world of IoT. And so far we have conducted few sessions in major colleges like IP College, one in Noida, I can't recall the name, IMS Noida, sorry, IMS Noida, and then one in Gurgaon. So our aim is to get in touch with more and more faculty, so that the faculties are the key piece. Basically, they are the first point of contact for the students. So student is something we are targeting, so that they get they get into the domain as soon as possible, so that we get more hands. So second program we are running is student ambassador program. So any college students, here, we invite you to, come with us and be our volunteer, work with us. We have fantastic, volunteers standing behind you. They are the college students, and they have been supporting us to, enormously to conduct these workshops. So there is one more initiative that has been running is open project, so that has been run by Nikhil itself. So the idea is to evaluate different project ideas and collaboratively work on them, so that we can help us in helping the community or doing some social cause. So two of the solutions which we have been working on is the pollution monitoring and smart home. So there is a startup catalyst program. This program we started very initially, like like back in 2015, where we wanted, to give a platform to startups so that they can come and promote themselves on the dais and so that people can know about them. So some of the partners, which joined us in the beginning were the Bristol and IoT INA, and followed by Banao, Womenite, iHelp, IoT News Portal, iHealth Connect, and Pro. So you can collaborate with us. If you have, you can become a knowledge partner, you can become a location partner, you can become a community partner. You can come as a speaker or as a volunteer, or if you can help us do the media promotions, we'll be happy to help. So these are some of the highlights, which you wanted to show. These are some of the comments which we have received on the meetup. So we get good comments, we get bad feedback. Depending on how we run the things, sometimes people like the things we do. Sometimes people don't like the things we do. So we encourage you guys to write the genuine feedback so that it gives us an opportunity to improve. Also, if you write good feedbacks, it gives an opportunity to smile. You can follow us on these handles. So we are on the internet, on meetup.com. We have a website, iotncr.org. We have a LinkedIn group, Facebook, Twitter, whatever social media platform you follow. You can connect with us. Thank you. Yeah. So with this, I would like to invite Nikhil. He'll be, he and Mani will be taking your blockchain session today. So thank you very much. Welcome, Nikhil.
Once again, thank you everyone for joining us. This is a blockchain session, just in case if you have you have enrolled for the session and you are sitting here. So we'll go through our blockchain session in this 2 hours, and what our primary objective is to first of all learn why we need blockchain. What is the purpose of blockchain? Is it a hype or is it not a hype? Is it something real, right? And then we have to understand after that what are the areas, which the applications can be done and at what stage they are. We can talk about in general how the market is adopting it. And then we'll move on to hands-on. In hands-on, we'll be taking you through 2 areas. One is the composer, that is the IBM product. Because the shortage of the time, we'll keep it minimalistic so that you have the idea. And then second is Ethereum blockchain. On Ethereum blockchain, we'll be taking you through how do you write smart contracts and how you can see it's being executed. Right. So if you have any questions, I do encourage them. But in the interest of time, I would request you to keep it for the last. In case if it is unavoidable, then definitely you can ask us. So we are the speakers for the session. Myself, Nikhil Gupta. I am, apart from our day jobs, as Jasmeet said, we run this community. I am one of the co-founders of IoT NCR. And I have 11 years of experience in capital markets and telecom. And I have my experience from development also, program management, product management. And these are the roles that I have played. I have been interested in blockchain since last more 1.5 years. And because capital markets are one of the target industry for blockchain, it's coming up there in huge capabilities. I've done a lot of POCs involving bond issuances, loan issuances. And I have myself with Mani Madhukar. He is from IBM. And Mani, why don't you speak for yourself?
Hey, hi, good afternoon. My name is Mani Madhukar and I am part of ecosystem development team at IBM. So what I primarily do is I work across with ISVs, startups, academia, and I cut across different technologies at IBM. So be it IoT, be it data science, be it blockchain, cloud. So my primary role is about educating and adoption, assistant adoption of all these technologies across different customers of IBM. Thank you.
So we are starting with the session now. I think, Mani, I would request you to please come back on the stage again and start with the session.
So, without further ado, let's start this. So how many in this room are primarily already working on blockchain? I want to see a few hands before I start. Okay, 1. Oh, that's it, is it? Okay, 2. I'm asking because I want to really, get the baseline from where to start my conversation. That's the reason. Okay, then we'll do a quick understanding about what blockchain is, and then we'll go further with how to do a implementation of a blockchain. Okay, so So normally blockchain or technology like blockchain is intended towards businesses, right? So just a brief recap of businesses, how businesses work. Now businesses normally don't work in isolation, right? They basically work in groups in tandem with multiple business partners, right? And because of those association in business, you happen to generate wealth in some form by offering a service or by offering a product or something. And while you actually do a business, you basically form some sort of markets. It can be a private market within a closed group, or it can be a public market as such, right? And in order of doing all of this, you particularly have two types of assets, right? A tangible or a non-tangible. I'll not go into this. But then to do all of it, ledgers are they have been at the backbone of businesses ever since we've been doing business, right? Now, whatever the ledger has actually is being governed by something called as a contract, right? So we have contracts in place which govern how the businesses are being done and what ledgers are supposed to record, right? Now, what has happened over the years is how blockchain is going to change this whole scenario is like this. In a current scenario, what happens is businesses talk to each other, right? So let's say there are a couple of business partners, A, B, C, D, and there can be a bank in this business. There can be an insurance company as well in this business, right? Now, each of these business network partners happen to manage their own ledgers, right? They would have their own isolated ledgers. So what it means is, at a certain point in time, so let's say today, 8th of March, if all of them are into a business agreement, A will have some entries in his ledger, B will have some other entries in his ledger on the same transaction that they're having. So that means they will have a disparate state of a transaction, right, at any given point in time, which is really an inefficient way of managing and doing businesses, and it's extremely vulnerable for a lot of conflicts, right? That's what happens. Now, what blockchain intends or what blockchain offers to do basically is replace this individual ledgers across these different partners and replace it with a shared, replicated, and a permission ledger. Now, please remember when we are having this discussion, we are actually having this discussion in respect of enterprise blockchains, okay? That means we are talking about private blockchain. We are not talking about a public blockchain like a Bitcoin, right? So please keep that isolation between the two very, evidently and clearly between in the minds. So what happens here is, you have a shared, replicated, and permission. Why permission? Because in a business, you happen to know your business network partners, right? So you would know who's going to join the business and who is going to be working with you. So you have those permission participants coming into and joining you. Okay. Now let's understand another good point here is, it is shared, means nobody has an isolated copy of view. It's a single view across the network with all the business network participants. Okay. And it is replicated in real time, right? Compared to what happens is we do a business, we do a consolidation at the end of the day or maybe a certain T plus 2, T plus 3 days, right? It basically is a real-time consolidation, which is really makes it very, in terms of efficiency, great. Now, today when you actually go to a bank and deposit a check there, it normally takes around 3 to 4 days to reflect in your account, right? Now, with the blockchain-based banking system, the moment you deposit a check in a bank, you may actually have it the next moment, maybe another 2 minutes. That's what it takes. What it effectively means is that much actually liquidity back into the system, which would otherwise have been unusable. You couldn't have used that whatever money you deposited. So blockchain is in a way actually going to revolutionize the way, businesses happen. Okay. And let's come on to the basic, okay. So I basically made it a point that I'm not talking about Bitcoin here. I'm talking about and why not? Because businesses can't thrive on anonymity, right? Businesses need identity to get mapped who is doing what in a business network, right? And so how many here are familiar with Bitcoin? Oh, that's a wonderful number, right? So when I asked blockchain, there were only a couple of hands. Now I'm asking Bitcoin, there are, huge numbers there. Oh, that's good to hear actually. But then it's not so good as well because, okay. So I'm more interested in the enterprise side of the blockchain, guys. So I'll more focus on that piece, right? So 4 key things which are, very essential for a blockchain-based system. 1, shared ledger. We talked about it, but the important point is the shared ledger is append only. You cannot delete what you have written to this ledger. It's like something etched in a stone, right? So that means whatever you happen to write on this ledger, you need to take some, certain steps there to ensure that you're not writing anything wrong, right? Now, what you write is actually controlled by something called as a smart contract, which is the backbone of any blockchain-based system. Now, smart contract or a chain code is nothing but, your business contract, your terms and conditions of doing a business, which are hard coded in a software, in a program, and are autonomous. It's put on a network and it runs autonomous. There is no manual intervention once deployed, right? So it's no more prone to any manipulations. It can't be done anything that way, right? Okay. Now, having said that it is a shared network, it's a shared ledger, there is an immediate concern that how A and B are having a different view. Is my data getting shared by B? Is my data, which should not be shared, is it getting shared by the banker? No. The reason is there is appropriate cryptographic mechanisms which are put in place so that even if A has the entire ledger with it, it cannot see what it is not supposed to see. It can only see what is cryptographically supposed to see, what it is destined to see. The other part is hidden with it from the particular vendor, A, B, C, or whatever. Now, and the fourth part is, of course, the inherent trust because of which the system provides, right? Because the technology provides. Now, why this? Because the transparency is built in, because whatever you do, you are basically obtaining consensus from the other network partners. Now, this is another good part I wanted to then touch upon, consensus. Whenever A wants to write anything on this network, on this ledger, sorry, he basically needs to obtain a consensus from a certain number of people on this ledger. Now, please do not confuse it with a proof of work of a Bitcoin. It's an entirely different thing here. We'll take that discussion in a while, right? I have a slide on that piece as well. So, consensus, provenance, immutability, and finality. These are the four major benefits that blockchain provides to the business today, which really can make a difference to the businesses, okay? So we talked about shared ledgers, we talked about smart contracts, basically encoded in programming language. Now, my whole conversation today is going to be focused around Hyperledger. Now, Hyperledger is an open source, under Linux Foundation. It's an open source project under Linux Foundation, which has almost like 150 partners, right? Different categories, premier, associate, general members, but then around that many a number. Where IBM is one of the partners there, okay? We are just a partner, just like an R3 or an Intel or a JP Morgan or a DTCC or, all these guys. Okay, so all the conversation today from my point will be in terms of Hyperledger, okay? Let me go down further. So we already talked about the participants will actually have a privacy built in by cryptographic mechanisms, and the ledger is though shared, but then the participants will have an entire privacy about what contents, who is seeing what, okay? Okay, now this is the point I wanted to make, right? Public blockchains versus private blockchains. So we're talking about a private blockchain where network members are known to each other and they basically know whom they are dealing with, right? Okay. Now, transactions are normally confidential between these business network partners, and they are masked using something called as a transaction certificate, a T-cert, or an identity certificate called I-cert, right? So that is a concept that we'll talk about it when we come to the certificate authority part, the CA part. Okay. Now, how is it important for the business, right? Now, let me give you a recent conversation I was having somewhere. Now, blockchain has opened avenues like never before. Anybody in this room familiar with how chit funds work? Chit funds. What's the first thing that comes to the name when you hear chit fund? Scam. Yeah, exactly, scam. Now, with the expense of a country like India, right, where there are all types of investors, right, from a small, marginal to, big wigs, there is a big segment which is unorganized in terms of local, small investors, which normally invest in a chit fund, either a company, chit fund company, or unorganized sector. Now, this particular sector had been manual for ages altogether, and we had been seeing all types of scams. Now, recently we started working with a startup in Hyderabad, and we had a meeting last month with Government of Telangana, IT Secretary, and the other departments there. Now, what they're trying to do is they're trying to automate the chit fund process, and they're trying to bring it on a blockchain to avoid all those forgery, all those malpractices and all. Now, strangely, when we were talking to all those secretaries and, those revenue department officials, they were still insisting on, when I explained the smart contract, it's all autonomous, no human intervention, they were still insisting of, what if something goes wrong, how do I go and, correct things, I said, it's not possible that you actually make a wrong thing here because it's all foolproofed. So when there is no wrong, there is no scope of manipulation. The moment you open up that back door, it's all, the gist is gone, the basic crux of the technology is gone, right? So, yeah. Now see this, chit funds had been a lucrative business that people have been exploiting in a very wrong way. But what came around in that conversation was an entirely new thing. Why can't we insure chit funds? Now, insurance never had that use case forever. This is something, a new business avenue getting opened up for insurance. Why? Because blockchain provides that trust and transparency which an insurance company can now go and insure a chit fund, which was not the case earlier, right? So blockchain is actually an enabler for all sorts of use cases. There's so many more that I can talk about because I work with a lot of startups across the country. So n number of ideas are there, which are being worked upon by different sectors in different sectors. Okay. So we're talking about this, right? It basically creates new values, it reduces risk and optimizes the ecosystems, right? Okay. Now, where is this already being used? Now, I'm sure, you might have heard about a couple of consortium already getting worked upon in India, right? There is one by the name BankChain, right? Which is already having some 30 plus participants, not just Indian banks, but then also overseas banks, right? Now, what this startup is trying to do, it's basically has identified some 8 use cases, okay? And it is trying to create a solution for these 8 use cases in a sequential way, with KYC being the most low-hanging fruit, and then AML and so on, right? So the point is, and RBI actually had been very, keen on doing this piece as well. If you go to the insurance, IRDAI has basically pushed the insurance companies to implement blockchain in some way there, right? So there is a push coming from the, the regulators, the government in terms of adoption of the technology. Why is that happening? I can actually cite an example of government of Maharashtra as well, and a couple of more governments which are doing a lot of blockchain based, playing around with those things, like the registries for the houses, like RAN records and all those. So they are playing with all those areas, in a big way. So the couple of typical examples where we see a lot of adoption from a blockchain point of view, one is supply chain. Big time, right? So Walmart is already having a live solution on supply chain in China for a couple of products, including pork and a couple of veggies there. Mangoes, yeah, of course, right, mangoes, yeah. So there is already a live, a solution which is available there. Okay, so this supply chain is really betting big time on blockchain. The reason is today what you eat, what comes to your platter, you don't know where it is actually coming from, right? The idea is to actually trace the route where the thing actually came up from, be it a fish caught in some ocean, be it some product grown in some field somewhere across the country, right? You want to catch it from there, and then you want to trace the entire supply chain of that particular product till it arrives with you, right, the customer. Okay, audit and compliance. This is the biggest beneficiary, guys. Reason is, with a blockchain, the audit trail is inbuilt into the system. You don't have to have a separate mechanism for audit and compliance. So what it means is, effectively, that 30 to 40% of money that you pump in, particularly for audit and compliance, is taken care of automatically by the system without any separate provisions. This is one of the biggest benefits when it comes to the auditing point of view, from a regulator's point of view, right? So that's really good. Okay, let me go down for the letter of credit. We all have seen a recent example of letter of understanding, right? How it has been misappropriated and misused across and cost what we have seen it, right? And the worst part is technology had been there for long. The only thing is there had been, no coupling between the two technologies, thereby existing for a long time, right? Which is causing this whole problem. So the moment you bring in a blockchain angle, there is no scope of a fraud or a scam or a cheating or a manipulation. It's all taken care of automatically. Okay. A couple of examples industry-wise, where we are already seeing a lot of traction of blockchain adoption, be it financials, be it public sector, be it insurance, be it manufacturing, we talked about, right? Boeing is already using, a blockchain for the component tracking system, maintenance tracking mechanisms, they were that way. And so on, a lot of them. Loyalty programs, a lot of banks, including SBI, is already having a loyalty program on blockchain. And healthcare is going to be the biggest beneficiary of all this. If you see, there is a government, there is a government body that they are formed in India, which will take care of the electronic health records within country, right? Now, the moment you bring in a blockchain angle, you can actually have the customer, means the patient, controlling his data, or who accesses it in what way, which has not been the case. And it is being implemented even globally. US, where there already a sound health system, they're also trying to bring it on a blockchain, right? Okay, now how to actually adopt to a blockchain? This is very crucial, guys. For anybody who is trying to adopt a blockchain, one needs to understand how you can, because blockchain is typically suited for use cases where there are multiple parties working with each other, right? So, so consortium is the best way of adoption where you have all these multiple stakeholders brought in together. Now, that's the reason I mentioned the bank chain case. That's the reason I was mentioning the insurance case. You need to have a consortium formed in order to get those. So Walmart is having a consortium of all the suppliers at the back end. They're all brought up together and they're on a blockchain so that the implementation is seamless, right? Yes, and then you should understand, which sort of market. It should be definitely for a high value market. It should not be a low value market implementation. The reason is blockchain technology is still maturing and it is not the solution for all possible ailments for us, right? It's only suitable for certain use cases. So you need to identify very critically that whether blockchain is a suitable technology or not. If you see the example of Everledger, which is already a live example for diamond trading, right? It's a startup which is doing this, right? And the solution is on blockchain. And then if you see Northern Trust, which is already doing equity trading on blockchain, it's again there. It's a live solution out there in the market. IBM recently came up with Maersk. We came up with a joint company together for container management system on blockchain. So such is the potential of the technology that two giants of different areas are joining hands with the solution for go-to-market, right? Okay. So regulator is a key player. Please understand this point. Unless the regulator does a push, nobody will be willing to actually come on board because nobody wants to get hammered for any misdeeds. Okay, so industry groups are another good way, and of course the market makers, right? So that's one of the ways for adoption of blockchain that's to be taken consideration. Okay, let me go back and try to give you some more about how maybe IBM can help you in adoption of a blockchain-based systems, right? Okay. Now, IBM is a part of something called as Hyperledger I talked about, which is our Linux Foundation project, right? And it wasn't early. It was just December 2015 when we started with this Hyperledger project, right? And today, within a span of almost like 2 years, it's almost like 150 people, 150 logos which you see around there. These are all Hyperledger members, be it Premier or General or Associate. Now, if you see there at the top, right? Accenture, Airbus, Airmax, DTCC, Intel, R3, JP Morgan. Importantly, you will see logos there which have their own solutions, right? R3 has its own Coda. Despite that, it basically is a part of Hyperledger. JP Morgan has their own Quorum, right? But then they're again a part of the here. So my point is the reason people are seeing blockchain as a real technology which has a big potential in due course of time. And you know what? In due course of time, you'll see a lot of consolidation happening from all the platforms that you see. There are so many of them there. Coda is there. There is Quorum is there. Multi-chain is there, and there are so many others itself there, right? So in due course of time, you'll see these blockchains talking to each other, all getting consolidated in a single framework. That is where Hyperledger will definitely make a big mark with the vast strength that it has of different logos, 150 plus, which is the biggest one right now. Okay. So what I'm going to quickly do is I'm going to quickly take you through a few of these. So today we are going to do a small hands-on on Hyperledger Composer. Now this particular tool is again an open source platform under Linux Foundation. Now the benefit here is somebody who is not into programming, into hardcore programming, like a business analyst, even that guy can create a blockchain solution maybe in 10 minutes and just go around and show the value to the client. That's what is the beauty of this particular thing, right? So what happens here is the Hyperledger fabric runs underneath the entire thing. On top of that, Hyperledger Composer is a layer there, okay, which provides you with a JavaScript-like language. It's a modeling language wherein you can just have multiple typical English sort of constructs. So we'll see that. To create a business application, you can actually take down this URL if you want, hyperledger.github.io/composer. So today we'll be going down to this link, composer-playground.mybluemix.net, where this project is hosted, and we'll be working on the cloud to get a hands-on of the Composer, okay? So when we'll do it, so we'll expose this link. Please do not worry about it, okay? Let me go down further. I'll skip a few slides just to give you a clarity. What Composer provides us is 3 basic things it takes into consideration. One is it creates models. We'll understand models. It has a script file. It has some access control list, who can do what sort of things. Together, all of this is bundled into something called as a BNA, a business network archive, which can be deployed in lieu of a smart contract, So the moment you deploy this BNA on top of a Hyperledger fabric, it is as good as a smart contract being deployed on a fabric, right? So we will see that piece. So I'm going to quickly skip a few. I'll talk about that later when I'll come on to the hands-on part. And this is the second approach to get it started. IBM offers blockchain as a service on top of IBM Cloud, right? Wherein a user need not bother about the network piece of blockchain. They can simply go ahead and start with a smart contract deployment there. Yeah? So all that you need to come with your business use case, your business logic, business contract, code that thing and deploy it on the cloud, and it is good to go. You don't have to actually, have a network created, managed, and all that stuff there, right? So that's the beauty of this particular environment. We have been working with almost like 400 plus clients across the globe. A couple of them are already live solutions that I talked about, Northern Trust, Maersk, Walmart, and so many more there. A couple of just laundry list about, who all is doing what in this area. Now, a couple of good topics to understand what blockchain is all about. Now, this is a typical architecture diagram of who the participants are in a blockchain network, okay? I'll quickly touch upon this before I go further because this is important. Now, if you see in a typical blockchain network, these are the participants. And you see regulator there is at the top. So we are not talking about public anonymous blockchains. We are talking about permissioned private blockchains where regulator has a role to play. Unlike where we say governments don't have a role to play. We are saying, please get the government on board so that the solution is more acceptable. It can be scaled to, multiple stakeholders in that particular area. That's the gist behind, having a regulator there. And then there are a couple of blockchain users like multiple companies, company A, B, C, D. And these are few roles there. Okay, so I was talking about a blockchain network operator. So as I said earlier, all the participants in this blockchain network need to be on a same network. So what it effectively means is somebody needs to take care of the network piece, right? The networking side of it. So that is where IBM Cloud comes into play, and you are taking care of that, problem where somebody has to manage this. So this is the network operator. On top of this network, what you do is you deploy a smart contract, right? So the hyperledger typically is written in Golang. So you can have a Golang smart contract, you can have a Node.js smart contract written on top of it, right? And then you have a blockchain architect. Now, why an architect? Because blockchains needs to give you some sort of insight also as time goes, right? So there is an integration of artificial intelligence, machine learning, again coming into play to derive those insights from the blockchain things, right? And of course, when it has to be compliance, then again, a lot of stuff has to come from that piece as well. So you need an architect as well. And the good part is it basically integrates with the traditional, whatever you had, those processing platforms in terms of SAP or whatever you can bring onto the platform, they can all plug into that. And you have the provision of connecting all those traditional data sources again. Now, all of these entry and exits on a blockchain is primarily governed by that membership service I was talking to you earlier, CA. Certificate Authority, which provides you with those T-certs and identity certificates in order to mask the identity of the participants, right? Because you do not want to expose what people are doing in what way are they doing that. Couple of terms just to take you through membership and all. We already talked about it. I'm going to skip this slide. Okay. I'm going to skip few of them in case we'll come back for this. Now, in a blockchain, there are typical two types of data structures. One, a blockchain, and the other is a world state, which basically holds the current state of the data or asset, whatever you may say it to be. Now, a blockchain is nothing but a linked list of blocks. We'll see how it is, right? Now, this is this. If there is say, let's say block 15, 16, and 17, now a blockchain is basically made as a series of blocks, right? With each block containing certain number of transactions. The number of transactions is basically your discretion. You can fix it based on time, or you can fix based on number of transactions. Say 10 minutes, whatever comes in, gets into a block, or 100 transactions, whenever they happen, gets into a block, right? And the good part is the hash of this entire block is actually used to encrypt the next block. That's where this chain becomes immutable, right? You just cannot try to do anything with this, because the longer the chain becomes, it is just not possible to do anything with this, this type of a blockchain-based system. So that's why. So this is one is the blockchain. The other piece is the world state. So whatever is the change in terms of ownership or the current state is being recorded in the world state piece there, right? Which is typically a key value pair. Okay. Let me quickly go. Now, I'm basically talking about Hyperledger Fabric 1.0, okay? Which is about to get a new version of 1.1 in due course of time. Now, typically there are three types of peers, guys. Peers means nothing but business partners, business network partners, okay? Like a committing peer or an endorsing peer or an ordering peer. I'll just skip it for now, and I'll come back to it later if needed. Now, if you remember, I was talking to you about the consensus piece there, that before A can write to the ledger, it needs to obtain a certain amount of consensus from B, C, Ds of the world, right? Now, to get that consensus, there are multiple consensus algorithms which are already around, right? Now, proof of work is you already know, right? Typically, Bitcoin background, everybody will know, people do mining and they get paid, in lieu of that mining process, right? We basically, from a Hyperledger perspective, talk about either a Kafka Zookeeper or a solo no-ops. So in case your use case does not require a consensus, solo is the way to go, right? There is no overhead using this particular mechanism. In case you have multiple players, a big network, you can actually use a Kafka or a Zookeeper to basically streamline all those messages that are coming into the system, those transactions that are coming into the system, in a message queue like a Kafka to serialize them, okay? PBFT was something which was used in O.6 Fabric flavor.
I'm so sorry to interrupt. I request Ashutosh and Reema to just talk to Meetu, who's outside this hall. Yeah, you can continue. Ashutosh and Reema. Yeah.
Somebody had an announcement to make.
Okay. Actually, since we have a pause, I just want to announce one more thing. Sorry, Mani. This event is oversubscribed. We had 50 people, but I think on the spot there were another 5 to 8 people who have registered for it. So what I will request the people sitting on this area, if you can move your chairs a bit ahead, how much ever you can, so those people who are right at the door can find some space to come in and see the screen, because I think the lady over there is not able to see the screen, and there are 2 folks standing over there. So people, if you can please move your table a bit and a chair a bit here and there. Sorry for the inconvenience, but this is like a very popular session, blockchain. Thanks to Mani. They got 60 people actually assigned. We had asked them to put a limit of 50, but a lot of people were like dying to attend blockchain.
It's okay.
Okay. Mayur, please arrange more chairs for the people who are standing. Thank you. Thank you, everyone. Thank you so much. And one more announcement. I think I have done this to people who have been in the previous workshop. We have given you pamphlets about IoT NCR. Please, between the workshop, whenever you get time, sign up on meetup.com/IoT-NCR so that you are benefited from our future workshops as well. Okay? Thank you. Thanks.
One last thing. I hope all of you have copied the code from the USB that is being distributed across. If not, then you can get in touch with him over there. He'll distribute it. Right?
Okay, just to, again start the conversation about consensus, right? So let's say if there are 5 business partners in a network, right, and one of them wants to write to a ledger. Now the consensus actually says that out of 5, at least 3 should consent to what he wants to write to the ledger, right? And there is no cartelization here, by the way, because businesses, people know each other, right? Typically, we are not talking about anonymous networks here. So there is no cartelization here. So coming back to the consensus, to obtain that 3 out of 5 thing, we have a couple of algorithms. So we know that proof of work thing, right, which basically Bitcoin deploys. I'm going to talk about proof of elapsed time, which is a wonderful algorithm which is given by Intel, right? Intel, the Sawtooth Hyperledger Sawtooth project makes use of POET, right? Proof of elapsed time, where basically the execution time is basically randomized in the block generation, which is the best part here. Similarly, in a solo or no-ops, there is no consensus. We talked about this, typically used in Hyperledger Fabric 1.0, but then based upon the use case. Kafka is the one which is typically used again in Fabric 1.0, and PBFT was used in Fabric version 0.6, which is no more used now because we have a 1.0 available. Okay, so what I'm going to quickly do is I'm going to quickly stop here, and I'm going to take you through a few links which will help us in understanding how to do this. Now, this is the link I wanted you to open, those of you who are having machines and those are you who are having a laptop with internet connectivity. Okay, composer.playground-playground.mybluemix.net. Is it visible? Is it visible? Yes? Are you able to open it? Great. if possible, please take down these two URLs as well. I'll just explain what these mean to us. To access cloud, you can use this URL. It provides you with a lifetime free access of IBM Cloud, which you can make use of for anything like machine learning or blockchain or whatever. And this is a link wherein you can learn about blockchain and multiple technologies. I'll just give it to you. Oh, it's actually, oh, is it? Okay. Yeah, in the meanwhile, maybe you can. Is it good? developer.ibm.com/code/pattern is the URL. Okay. Now let me go back to my browser. This is the link, guys, okay? When you come here for the first time, you will actually see this link which talks about let's start blockchaining. Can you see that? Is anybody able to open the link? Still opening up for you. Okay, let me cover a few things in the meanwhile, okay? The other link that I showed you was this one. This is developer.ibm.com/code, the other thing there. And this link provides you with access to learning of all these technologies. See this? Analytics, API management, AI, blockchain. Okay. Okay, I'll just show the link as well here. Okay, that's it. Composer.playground.mybluemix.net. Okay, that's the link that you have to open. Now, in the meanwhile, just try and understand this piece as well. So it's basically something called as a code pattern for all these different technologies: containers, data science, data store, DevOps, gaming, IoT, Java, right? And so many more. Messaging, microservices, mobile, Node.js, Python. Now the point is, if you want to learn more about any of these, just click on anything. So let's say today we are talking about blockchain, right? So let me click on blockchain. So what IBM has done is, IBM has taken up some enterprise use cases and it has given away the code and the entire process for that use case, right? We'll just see what it actually means for us. So for blockchain, there are 10 code patterns, let's see this. Okay, see this. If you want to automate a business process using blockchain events, click on this. It will tell you the entire piece. I'll take you through one. If you want to make an insurance app using blockchain, this is the code pattern to go. If you want to start learning blockchain, first application, hello world, this is the way to go. Similarly, if you want to create a smart contract, click on this. Somebody is into foreign supply verification, FDA, click this. Somebody wants to build a blockchain network, click on this. Somebody who wants to have a hyperledger composer for a decentralized energy, right? Just the way we are doing for Australia and New Zealand, click on this. Somebody who wants to create a to-do app, sort of an application using blockchain, this is the one. And somebody who wants to create an application for, asset distribution, transfer, click on this. I'll just click on one of these so that it will give you a view what it means, how to use this. Now somebody wants to make a blockchain-based insurance app. Let me click on this. It's the coolest way to learn a new technology, and the link had almost like so many of them. Okay, let's see this. So it gives you an entire description, what it means, what is this use case about. See the overview. It tells you the detail about how insurance is using blockchain. Okay, how does it works, how does the app works. Okay. This is the architecture diagram about how the different components are talking to each other. You'll not find it anywhere else, right? It's a very good way of understanding the system, right? It gives you a clear view what has happening at which stage there. Then what are the different stages here? What all components are used in this solution? And this is the best part. You can either see a demo or you can also get the code. So I want to get the code. So I'm opening it up in a new window, which basically takes me to a GitHub repository. Okay, guys? Now this GitHub repository will have the entire code for this, which you can fork, which you can download, which you can use it in your own solution. It's available free. You can do whatever you want to do with this. See this, clone or download? Yeah, so the entire code is available there, including different peers, including how the orderer works, including how a certificate authority works. Everything is being made available. And if you scroll down below, you'll find the steps to do it. See this step for Mac user, for Ubuntu user, right? So it's a very easy way of learning. Now it gives you a steps to do this. Step 1, download Docker images. Step 2, run the application, the various commands. It gives you the entire flow. That means learning is simplified, so that you don't need anybody to help you, right? That's the entire motivation behind this. Any questions around this piece? Okay, we'll talk about the questions piece later then. And the good part is you can learn any technology for that matter using this approach. So I showed you all the different possibilities using AI, a data science, containers, microservices, whatever you want to learn. The code patterns are basically available for almost everything there, right? Okay. So now let's go back to the Hyperledger Composer, okay? In case this link is open, is it open for you now? Yes or no? Okay, great. So you would have seen the first, a window there which says let's blockchain, right? And you will see something called as deploy a new blockchain network. Now, if you remember my slide, I was telling what a blockchain network is, basically a composition of model, access control list, and those things, right? Let's click on this. So let's say I want to deploy a business network, right? A typical business network to understand what is it about. Now, if you scroll down, you'll find some sample networks available to work with. Now, there are so many of them. For animal tracking, for bond, buying and selling of bonds, for a car auction network, for a supply chain for perishable products like a banana, fruits and all those stuff. Something like a digital property network where you have ownership to be transferred across and the likes of that, right? So, yeah, you can just pick up one of them. So, maybe pick up a perishable network. Click on perishable network. Okay, and once you click on this, it will show you what this network is about. This network contains 4 participant types, 2 asset types, and 4 transaction types. That's what we talked about, right? That's a BNF file. Click on deploy. I have already deployed it, so I don't want to click on deploy again. You click on deploy for this matter, okay? It'll take a minute or two. I'll go back to my wallet. So I've already deployed this. Once it is deployed, you will see it something like this, like a business card like this. Anybody able to see this? Great. So click on connect now. So the moment you click on connect now, you actually connect to the business network which is defined here. Click on the readme.md file which gives you the entire details about what this is about. Now if somebody who has to read, it's basically a network which defines a relationship between growers and importers. Somebody is producing, somebody else is importing that product, okay? So what are the participants? Grower, importer and shipper, right? 3 people in this network. What are the assets? One is the contract, the other is the shipment that the product is being shipped, right? What are the transactions? Now, since this is a perishable product, you are actually having a air-conditioned container to ship the product, right? So you want to manage the container's temperature all the time. So that, let me give you a use case. So this container is being taken from Delhi to somewhere in Chennai, right? Let's say this. And it is shipping bananas from Delhi. Now what will happen is, sure. So what will happen is, bananas need to be maintained at say 0-degree temperature all through the transit so that they don't rot, they don't go black, right? When they actually land with the importer, right? So who all will be, let's think about a broader use case. Not just the grower, shipper, let's have one insurance guy also a part of this blockchain network, right? Because he has to insure the product during the transit, right? Now let's say an insurer is also here. Now what will happen is this IoT enabled container is sending the temperature back to the gateway or back to the blockchain network every hour, okay? That 0-degree temperature, -1, -2, +1, +2, right? Whatever temperature is there. And all of these 4 people, grower, importer, shipper and the insurer are on the network which are monitoring it. So that the moment the temperature shoots between, ahead of 5 degrees centigrade which is not acceptable or 10 degrees centigrade which is not acceptable, the insurer sees the product is going to rot by the time it's going to land, right? So what it can do is it can dynamically change the insurance value of the product, which is a new use case, which was not there earlier, right? Because, and then at the same time the shipper can be billed for the losses. Because till now we cannot fix the responsibility. Here we know when the product was with shipper, then the container shot the temperature, right? And hence he should be the one, pulling in for the losses there, right? Okay, let's go further. So please copy this code here. This code will simply create a demo transaction for us, okay? Copy this code. Now see this, this is a define tab, there is a test tab. I'll explain what this means. This is a define tab, this is a test tab. Click on the test tab, scroll down, you'll find a submit transaction, okay? Paste that code here and click on say submit. Oh, because it's already existing for me. For you, it will successfully execute because for me, former@email ID is already existing. See, if you see my grower participant, there is already a user available there. Similarly, there is already an importer which is available there. For your case, it will happen now. Okay. Now, this is the contract, guys, which is running the entire thing. What the contract says is the arrival date time, the unit price for a particular product, the minimum temperature is 10 and the maximum temperature is 10 and the minimum is 2 and the penalty factor is 0.2. So what it means is the moment the temperature goes beyond 10, right, the product is going to start perishing, and hence insurer or the buyer or the supplier can know that the quality of the product is deteriorating, right? Okay, so let's go back to the define tab. If you scroll down further, it will give you a few more sample transactions to push in the temperature reading into the blockchain network. Right? This is what the entire thing is all about. So this is actually a very easy way of doing things. Let's understand what is there in the model file. So a model file is nothing but a mention of what is the product, who are the various participants, right? Who are the actors here? What are the transactions here? Now see the access control list. It allows who can do what on this network. For example, all the participants can access all the resources, right? But a grant business network is actually given to all resources. You can actually control this. You know, you can allow, you can deny. So it's basically an ACL, typical ACL, which allows who can do what on this network. Okay. This is the basically script file which has various transactions, functions listed, what is happening at what instant there, right? Okay. So what I'll do is I'll leave you with this. You can play around right now, and in case you have anything, any queries, feel free to query, write to me, tweet to me at @Madhukar, okay? And you can always have captured these links which you can refer to, right? Now I'll ask actually, Nikhil to take over and talk about the Solidity piece that he wants to take you through. He wants to take up a smart contract piece with you using a Solidity platform, means an Ethereum platform, right? Yeah, thank you.
Thank you, Mani. Thank you for your time. All right, guys. So now in typical sessions, in typical classroom sessions, when I was doing my MBA and all, so class participation must होता था. बिल्कुल वो नहीं मिलता था. Class participation नहीं है ना तो चलता नहीं था. So now it's time for class participation, and because it's Women's Day, so we'll start with the women in the house. So. Okay, so what have you understand so far with the blockchain? Ma'am, can I request you to tell us what is blockchain? And it's okay, I mean, it's because it's an introductory class, so it may be that there are some concepts which are not clear. We can take you through that. So what so far have you, understood about blockchain, and how blockchain is different from a normal database? What makes blockchain so popular?
I don't have answer for the second question that you have asked. So the blockchain is the block of number of transactions that are basically secured, and there are multiple blockchain networks that are private and public. So the session was basically for the private networks, and they are secured, replicated, and within the enterprise permissionable data that captures the transaction between, or the ledgers, or the information about the assets between the multiple clients or the companies or the insurer or any other parties, you must say. And so how you connect to them, how you maintain your ledger, how you define the security within the blockchain system is about the.
So I think that's a very good answer. And to the second part, I'll let you know, guys. So the question was why blockchain is different from a normal database. So why can't a normal database solve our problem today, right? So one thing that's very important is trust, right? Now we have central regulatory authorities, or we have a company. For example, you sell shares to me and I sell shares to you, right? The problem could be that you may be exposed to a credit risk, or I may be exposed to a credit risk. I may not get money from you, or I may not deliver my shares to you, right? So that is why exchanges came into place. That is why central, counterparties clearing systems came into place, and SDL came into place. So what do they do primarily? They primarily ensure that if I am coming into a transaction with you, I will not default and you will not default. The moment I says that I have bought a share from Mr. X, let's say I'm buying a Tata Motor shares at 432, right? So right now it's pretty down, but okay, just a hypothetical number. So the guarantee that the central counterparties, the central agencies provides us, that's what is the function of them to give us a trust, right? Now blockchain is basically moving us to that trust only. The problem with a database could be that there's no way you can trust it. So for example, a simple thing could be that if I'm capturing hourly videos here, a CCTV camera is capturing the videos over here, and then something wrong gets happened in some of the place, what is the guarantee that whenever the police starts their investigation, the camera feed is not modified, right? It could be modified. Now, the way it doesn't get modified via blockchain is that, of course, it requires a huge implementation like money has taken us through, right? And what will happen is that if I am able to read that chunk of data, an hour of data, and hash it and save it on a blockchain, nobody, if anybody changes that data, come back and change the cam feed data, the hash will not match. And hash is registered on the blockchain, and that cannot be altered. So if you see on your screen, see this block, as Mani was explaining, it's a chain of blocks, right? Every block is referring back to another block. So you have block 51, 52, 53, 54. Now why it becomes so tough to tamper it, is because that the blockchain is getting bigger and bigger every time. Now suppose I wanted to change block 51. What do I have to do? If I change the block 51, if I change the hash of that block 51, the record in 52 will not match because it would not point back to the same hash, right? So the chain will get disturbed. There's a concept of the longest chain, and there's a concept of forking it out. So if I try to get into block 51, and if I change it, I'll have to replicate the entire chain, right? And that involves a lot of computing power. And this requirement of power is what is detrimental. It's one of the parameters that makes it detrimental for an attack, which could result into alteration of many blocks. So alteration can happen. What people can do and what has happened, that they can fork it out. So for example, if I've changed block number 51, I can get computational power and I can make my own chain. So for example, instead of block 52 pointing to this, I can have another block 52. And then block 53, 54, 55. It's hard to detect at that time that which is the right chain. But what will happen, the original chain will keep on growing. Everybody cannot hack everything, right? Anybody cannot hack everything. So that is how, that's one way we can figure out the longest chain. And we can say that, hey, something wrong has happened, right? So that is why this blockchain technology, the trust part, so like what the example Mani has given. So suppose you are transporting something, right? Now you are into a business of medical, you're in a business of chemical or medical supplies. Now you want to ensure that the temperature is maintained throughout the shipment. If the temperature is not maintained, right, then the product will not be useful. But then how do you guarantee that was maintained? So if you are a supplier, right, and if you say that there's a third party, okay, they will maintain the data, right? They will capture the data of all the sensors, they will maintain it. What if the third party themselves wants to tamper it? They can tamper it, right? So just I wanted to take a step back to let you know that why blockchain and databases, databases have been there always, right? But the trust that these people, that this technology is bringing in, sorry, not people, the technology, that's something that makes this famous, right? A quick example could be if I want to take you through what happens, it's a Bitcoin example. As Mani said, don't confuse Bitcoin with blockchain, because Bitcoin is an example of a public blockchain which is focused towards cryptocurrency, but blockchain has many other applications, right? Now in a Bitcoin example, what happens? So suppose the people who are sitting at that side, they are onto the Bitcoin network and they have launched a transaction. What will happen on a Bitcoin network or a blockchain network, if it is implemented in the same way as Bitcoin is implemented? We'll take those transactions. So for example, we'll take 10 such transactions, right? And we'll make a cryptographic hash out of it. The hash will be unique to these transactions, right? So what will happen? There is a concept of miners and non-miners. Where's that slides? Yeah. So on a network, there will be a miner and there could be a non-miner. A miner is a person who earns money on blockchain. So you must have heard that, yaar apna computer laga dete hain, let's get in computational power or Bitcoin kamate hain baith ke, right? So you must have heard, because this is something that's very famous these days. So what's the job of miner is to take that transaction, put that transaction in a block and solve a puzzle. So different networks can have different puzzle. So for example, what Bitcoin says that you solve a puzzle for me in a way that I have a long key, and whenever you are able to group these transactions and make a hash out of it, you make a new key for me. That hash should contain 3 to 4 leading zeros, and if the previous number was 39, you give me 40. Now to come to that hash, using the cryptographic keys, that computational power that has to be required, that is tremendous, right? And that is how the rule of the chain is maintained. That if Bitcoin says that, hey, okay, you can come with a hash, that's okay, right? But then the hash which is coming out has to be, so one thing is that that hash stays constant for a set of data it is capturing, right? 10 transactions there, hash will always remain same. You take those 10 transactions in future time, then also the hash will be same. But when you make it a cryptographic hash, right, that hash which is coming out, that should follow the rule. Bitcoin says that make first 3 zeros and last should be an incremental number. Now to come to that is a challenge. So that is why what can happen is that these miners who act there, they have to put a lot of computational power. And that is why they earn Bitcoins, and in Ethereum, you would earn Ether, and you have to spend in Ether. So that is how this technology works. And similarly, if I go back to this Bitcoin flow example, now once that block puzzle is solved, right, and they say that, hey, this is the cryptographic hash which matches with what is the rule set of that blockchain, that is when they earn money, and that is when the verification happens. Once they come out, then the miners and the non-miners also. So there are multiple participants, miners and non-miners. The role of a miner is to mine it, come up with a cryptographic hash. And once they have come up with a cryptographic hash, the role of a non-miners and the rest of the miners is, right, to validate whether it matches that rules of the blockchain. So this was something really quick that I wanted to bring forward. So is this clear that why blockchain is needed? What is the difference between a database? Why blockchain helps? And how does it help? So now let me take you through a hands-on example of Ethereum. Right, so what is Ethereum? Ethereum is an open source public blockchain again, just like Bitcoin. Bitcoin is also Bitcoin is a cryptocurrency based blockchain. Ethereum, you can have a cryptocurrency platform on top of that if you need, but if you don't need that, then there are many other things that this cryptocurrency, apart from cryptocurrency, that Ethereum provides. So it's an open source public blockchain. And what is Ether? Ether is the cryptocurrency that is used to trade on this Ethereum platform. So every time you make a transaction, you'll have to pay Ether to get that transaction verified and get that transaction successful. And then Ethereum provides you virtual machines in which you can run your code. So I'll come to that, what does that code means, right? And then gas is something that is a term which measures how much processing power you have consumed, and then based on the gas is the processing power, how much of that you have consumed, and then based on that, how much Ether you have to pay. So Ether and gas are interrelated. Once you know the gas, you can come up with the cost formula and come to Ether, right? So in short, that is That is Ethereum. Now, coming to when I was talking to you about the code, what does that code means? So if I forget about money, right? Money itself is a code, right? Cryptocurrency is a code. They say that if I hand over money to person B, then it has to follow certain rules. The money gets credited into his account, and that is how we say the transaction is successful, right? But if we forget money, if we say that let's talk about the asset which are changing hands. So let's talk about car, so you can buy and sell car. So you're trading on car, right? Now, when you're buying and selling a car is again an asset, right? So instead of money, you can sell car. Now, but how the car selling will actually happens? For that to happen, you have to come up with certain set of code. That code has to define the rules that, hey, input value of this car, for example, these are the number. What that code can do, it will take the input as a number and verify it with the authority, whether it's a registered code. This is pretty much similar to what we have today as well, right? And then what are the features of that car, for example, who is party A, who is party B, what are the source of funds. You can capture all that information as a user input from whoever is getting into that trade. And then record the output of that, all these inputs onto a blockchain, which is Ethereum here, right? So that's how a car trade will happen. So nothing fancy about it. I mean, the main thing is that you have a set of required inputs, which you have today as well. You compute it, you get output of that, and that gets registered on the blockchain. So that's why it's often called Internet 3.0, right? So you would have heard Internet 2.0, now it's Internet 3.0. They call it DApp. DApp is decentralized apps. So what is a DApp? DApp says that you have a code, you may have a front end, which could be on anybody's mobile phone or web laptops and all, which can run there. But the backend code of that will run only on the Ethereum blockchain. That's what they say, right? And that is why it is called a decentralized app. So app runs on your machine, but the code, the server side, instead of server, they have a decentralized peer-to-peer network like Ethereum. That codes run on there, right? And that code, what that code will do, it will verify whether all the terms that are laid in the smart contract are adhered to or not. So in a car purchase example, when you're selling the car, I said that input parameters could be the condition of the car, what was the number, when it was purchased, right? And then certain reading about the car, like how good is the engine and all. So that input will still stay as the manual input, right? And party A, party B names, their Aadhaar card details or whatever, they still stay a manual input. But when it goes on to the blockchain for execution, what blockchain will do, it will verify whether, for example, I can write a code in blockchain which says whether the Aadhaar number is right or not. So I can, that can make further calls to get the Aadhaar number checked, which happens today also, right? But the good thing is, when the blockchain is checking all this, it is running certain set of code. That code can never be changed. Once you have made a smart contract means the lines of code which has to run and say that yes, everything is okay. Once that is made and deployed on the blockchain, that can never be changed. And that is how it adds to the value. So for example, if I made a code, right, I'm a dealer, I said that, okay, or say if I'm someone from the government representative, and I say that this is how the car transaction will change, car trade will happen. But then if I'm able to go back to the set of codes, and if I say, okay, let's comment out, let's not verify Aadhaar any longer. Let's comment out that code, right? Then that verification will not happen and fraudulent transaction would happen. People with false ID cards may get the car, right? But you cannot change that code at all. Once it is deployed, it's deployed forever. The only way to stop using that code is to kill that smart contract. You have to invoke a function kill, and you have to say that, okay, this is killed now. And this is a newer version, which again is not simpler, because when you have a newer version, you have newer set of addresses, right? Not everybody can get a newer version, and you can easily get caught that who has created this newer version, right? Basically, it's a new code in itself. So these are the hand-on components which we'll go through in just a minute from now. So one is Ethereum that I've talked about. Solidity is an object-oriented language. So it's basically object-oriented, but it's more geared towards contract. It's made on top of C++, Python, and JavaScript. And this Solidity can run on Ethereum virtual machine. Now, what is Ethereum virtual machine? EVM is a machine, it's kind of a VM, which Ethereum has provided that you can go there and you can run the code. But we cannot use that because that will cost us a lot right now. We have to make an Ethereum account. You have to put real money into it, buy some ethers out of that, and then only we can do it on an EVM. So instead of an EVM to run this Solidity code, we will instead use a local browser. What that browser will do, that will run a small mini blockchain on our system, on a browser itself. We call it a JavaScript VM. Instead of an EVM, we call it a JavaScript VM, right? And that's how we'll run and check it. Now, the third component, that Remix is it's ID. It's a browser-based Solidity ID. We'll make our code of Solidity and we'll put it in Remix. Remix will compile for us. We can give input parameters into Remix and it will give us the output. So that's how we'll go towards the hands-on. That will be a strategy to move ahead for our hands-on session here. Right? So I'll request everybody, because the Wi-Fi is a bit choppy, so please use the hotspots. And open the URL which you see here, remix.ethereum.org. So this is pretty much the real hands-on, so guys, get ready to get dirty. So the URL is mentioned there, remix.ethereum.org. So once you open the URL, you will see this ugly looking screen or good looking screen, depending on. Have you guys opened this URL, remix.ethereum.org? Make sure that you push the HTTPS. Guys, please confirm me back when you open the URL. Let me know once you are done, remix.ethereum.org. I'm assuming that the URL is open now. I think the internet may not be that bad. Is the hotspot? I think you have to put on your hotspots. So now you must be seeing this screen, ethereum.org. Right? This screen, this screen is basically the screen of Remix. And the area that you see highlighted in the pink is the area where the smart contract will be written. Okay. The area which you see on your right, highlighted in blue, that's the area where the compile, the run, and the deployment will happen. That's how that will happen. And the area that you see down below, that's in purple, that's the area where all the transaction logs will be generated. Right. And the architecture of this code is that we'll make a smart contract. That's a Solidity code. Right. The architecture is that we'll build a smart contract. That's a Solidity code. We'll compile it. We'll get the bytecode and the API. I'll let you know what bytecode and API is. And then that has to be deployed onto the JavaScript VM that we'll be using. So this is the architecture that we will follow. So now I'm leaving the presentation now, and I'm moving on to the browser myself. Please let me know if you're not able to follow. Right. So I've shared a code file. Has anybody received that code file? That's revenuesharing.sol. Right. Now you can click the little plus sign over here. You can open the plus sign, the folder sign right next to the plus sign. And you can go to that code and you can import that file from there. Can you please do that? Open the folder file, we'll open that solution file, and then I'll let you know what is written in that code. Open that solution file, and that file should come up over here. And on your left hand side, it should show under the browser section, revenuesharing.sol. Right, guys, I need some feedback. I know it's a post-lunch session, but it's equally for me as well. So revenuesharing.sol, is that file open in your browsers? Can I get a yes or a no or something? Yes? All right. So now let's see what that code is. Yes, you have to open it go to the folders section here, and go to the file which you have copied from the USB and open it. The website is not, the internet has a problem?
Is everyone able to open the file, revenueshare.sol? At least one person on every table, at least.
Guys, when you have opened the file, can you see the code written there in your file? Is it there? I think there's some copy problem. We can get you the USB.
Munish, you have the USB.
Right. You can copy from the USB again. Okay. Okay, so here is the code. First is the contract, the Pragma Solidity version. So we are saying that we'll use this version for our coding. Now we'll name this contract. The name of this contract is revenue sharing. So what is the objective of this code is that we'll define addresses. We'll define 4 addresses. It's basically 4 people talking to each other, and one person can share money, can share ether to other 3 people. So my account, if I'm sharing, my account should get debited, and the other people's account should get credited, and then this transaction should also be recorded on a blockchain. Right? That's the use case that we are doing today. So name of the contract is revenue sharing, right? Now I'm defining the variables. Address is a type of variable, and creator is the name. This is for the one who is creating this, contract. Then we have the, let me make it a bit small. Wait. Okay, then we are doing a mapping. Mapping is just like a map key. It's a key and a value pair. We are saying that the shareholders, that are the players who will be, getting the money, will keep their addresses stored here. We'll keep a number of how many shareholders we need. So for this, we are keeping it 3 because the use case says 3. Then there is an event. Now, what is an event in a smart contract? Event in a smart contract is essentially something which happens when the smart contract has done executing, right? So what happens that if you're integrating it from your front end, once the smart contract has happened, can help you in a callback, right? And it can raise an event which you can hear to an event. So in this session, the event would be disburse, right? Okay, that I have disbursed the amount. The amount is sent already. So that's the event that is being raised. And the people who are interested in getting that, the people who are interested are the receiving party, they can subscribe to this event and they can get to know, yes, this event has been raised. So that their web APIs can get to know. It's like a callback function. Then this is the main function, revenue sharing. This is the constructor. So remember, in a smart contract, the constructor has to have the same name as the name of the contract itself. So here the constructor is revenue sharing. We have the creator, the message.sender. Message is an object, that's a general object, which is being shared by whenever someone invokes a smart contract and you get the ID of that, you can call that message and object and get the sender ID. You have the number of shareholders and you are, where's the magnifier coming in? Okay. And then you can, this is a for loop, it just stores the number of addresses that you are getting. Now comes the main function, that is share revenue. Every time I have to share money with you, I have to share the revenue with you, I have to call this function, share revenue. And if you see the payable keyword, payable is a very interesting keyword in Solidity. It let Ethereum knows that this is the function that has the power of sending and receiving ether. Rest all code is something that supports these functions, this supports the implementation, but this payable is something that can send or receive ether. And that is why this payable keyword is very important. And what this is doing, this is getting from the message object, which gets populated with the context whenever the code is called, it captures the amount. And it takes that amount and then it gives it to the disburse event. What the disburse event will do, it will divide it into 3. Let me get to that as well. So you see the event disburse over here. Right? Now this event is defined there, and what this event will do eventually, this will divide this money equally into 3 accounts. Okay? And then you can see that has happened. And then this is the kill function which I was talking about. The originator of the contract can kill it, but they cannot make a new, but they cannot modify it. So I hope you have copied your this code, you are able to see it. Now let's go to your right-hand side. Right-hand side are your settings, compile settings. You have how do you run it, right? Because it's an IDE, you can deploy a contract in itself, right? And then other settings, and it is an it's an interpreter. It compiles as and when you are writing the code into it. So you can select auto compile, and you can just click start to compile. So once you say start to compile, you will see all these logs which you're already seeing on my screen. So far, I'll just take a pause. Have you reached here? Are you following me? Can you click the start to compile button? Can I get some confirmation, guys? Raise the hands if you are able to follow. Okay, assuming the others are witnessing it on others' laptops, right? Okay.
I just wanted to understand, like, what is the variable that mapping mapping of public shareholders. What is it exactly? What
So
is
that mapping is the key value pair. It stores the addresses which are allowed to work with this contract. So we'll define the set of addresses. That addresses get stored here, and only those addresses can work with this contract. So we don't want any random person to come in and be a party of this entire transaction. Right now go to the run section. Yes, you have to click the start compile.
Okay, I'm getting some errors.
You're getting errors or warnings. It's yellow, just like on my. It's a warning. Yeah, we can ignore warnings here. We'll only act when something blows up. All right, so let's get to the second tab. That's the run tab. Make sure you select the JavaScript VM as the environment. Why we are selecting JavaScript VM? Just because we don't want it to go on the actual Ethernet, Ethereum chain. Injected Web3 and the other options that you are seeing is for the third-party providers. Here we are using the remix itself. So we'll just use the JavaScript VM. So make sure you have selected JavaScript VM. And then below that, there's something called as account. If you open, you will see 5 addresses, and each of them has 100 Ether. Now, what is the beauty of Remix is that it says that because you want to test something or develop something, I'll give you 5 accounts, and I'll give you by default 100 Ether in each account, so that you can use that to test it out, right? And once you are sure, then only deploy it on the actual Ethereum. Otherwise, you have to kill it, and also your money will get wasted, right? So now here comes the tricky part. What we will do here is the first address. That's the address that I will use to transfer the money. The second address is something that I'm not using. That I just needed 4 here. Total, and there are 5, so I will not use the second address. The last 3 addresses I'm using as the receiver who will receive the money from me, right? So what I'll do is I'll distribute 10 Ether each to the last 3 addresses. From my address is the first address here, right? And second address is something that will not touch. So now let us deploy this code. We have the Solidity code ready. We have taken a walkthrough through the code. Now the next step is to deploy the code. Once it is deployed, then we can run and we can see how it goes. Yes. What about? No, so they have provided a gas limit. As I was talking, what is gas? That gas is something that gets spent every time you are working on Ethereum. So you actually consume gas. Gas is a measure of computational power, but you pay for that gas using ethers. This is the maximum that you can do. You cannot. So what happened when this smart contract, when it gets deployed, you will see right now, this, even if you deploy this smart contract, आपका जो 100 ether है, this first account, that is my account, and in your case, your account, you will see ethers getting deducted. Even for deploying the code, whenever the code is deployed or whatever you do with code, the miners who are on the Ethereum blockchain, they will run that code on their machine. So for example, a person sitting here can say that, hey, I have a huge computational power. I am acting as a miner on Ethereum. And a person like me who is deploying this code, even to show you guys, this code could be run on one of those miners' machine, and they will charge. And they will charge us in Ether. And the unit that they will say that how much computational power you have used, that's in gas. Okay? So now, so this is something really interesting you're going to witness here. So I hope you have selected the first address. Make sure that you have selected the first address. And please make sure that you have copied these last 3 addresses. It's a bit cumbersome process. So what you can do is go and select third address. And here is the copy button, just right next to it. I want you to copy all the last 3 addresses, because these are the addresses to which we will send the money. So we should have these addresses handy. Right? Please copy the last 3 addresses. I'll show you how you can do. You can quickly open a notepad. Select, highlight the address, that's the third address, click copy over here, right, and you can write it on a notepad. And then select the next address and write it on a notepad. So why we are doing it? Because you have to send to these addresses, so we must know what are these addresses. Guys, are you able to copy these addresses? You're up to speed now? Good. So hands who have been able to copy all these addresses out. All right, man, you are faster than me. No, I'm just making it in an array because you have seen in our code accepts an array of the addresses. There are 3 addresses. I'll just make it an array. Just put this box over here and insert it into the commas, inverted quotes, and separate it by commas. So guys, this is how it should look. Opening bracket and a closing bracket. And then in between all the addresses are inside a double quote separated by a comma. I'll give you 30 seconds to do it, and then I'll ask for a check if you're able to do it. All right, is it done? Have you able to copy these addresses? Okay, now select all of them. Keep it on your clipboard, and let's go back to the browser. Now make sure on the browser, because you are copying, maybe you have highlighted the last address. We don't want that to be highlighted. We want to highlight the first address now. Because now what we are doing, we are deploying this code. And this code has to be deployed, because I'm showing it on my machine, there should be my address. On your machine, it should be your address. Your address is the first address in this dropdown. So make sure that you have selected back the first address after copying all these. We'll keep the value as 0. And you can change V to Ether here. These are the different units. You can pay in V, you can pay in Ether on the blockchain. These are smaller units. V is a smaller unit to Ether. Right? And then select Ether. And then go to the first section. See, what is saying that to create this contract, give me the addresses who are eligible. Enter your address, enter all your addresses that we have just now created an array into this. So guys, are you able to enter the addresses there? Right, our objective, I repeat what my objective is. My objective is to deploy this contract. Because this contract is a one-time entity, I cannot do anything wrong. I have to deploy it right at the first time. One step to deploy it right at the first time is to pass the set of addresses which this contract can work with. Right, you cannot pass more set of addresses after that. I've just deployed my contract. But to deploy that contract, computational power has been used on Ethernet. Now, if you are a miner, right, at this point, what will happen that we'll say that, hey, I'm sending this code to you, and you have just digested it. You have not done any transaction on top of that. And you have said that if my line of code is very huge, then this cost will change. This cost is proportional to the code, the length of code that you're writing. And also, if you write junk code, then also you're penalized. You cannot say that you have made 10 functions and you're using only 2 functions. So you'll be charged for 2. No. If you have written, you'll be charged for everything. So that's an incentive that you will not write any junk code into it, which you can misuse, right? So you will write only relevant piece of code, otherwise you have to pay for that. Now, if suppose you are a miner, right? You get started paid. The amount has been deducted from my account, but you are getting that. In Bitcoin, because the valuation was very high, so people used to get really attracted with this. In Ethereum, the valuation is low, so people are less attracted, but it will improve, it will go further with time. Right? The rest of the account still stays 100. So now let's see what has happened. If I go to my log here, a permanent record is made on a blockchain, which says that from a particular address, this is a bit choppy because of the internet. I'm just trying to pull it up. It says that a contract, a transaction is being trying to made, which is not a transaction. Don't get confused because it's a deployment, right? From a contract address from to who is the owner. The address is coming here. It had so many gas as the limit. This is the cost, transaction cost or the execution cost that has been made. I'll tell you what is the difference between them, right? And this is the hash that is being made. This is the cryptographic hash that I was talking about. So in the chain that I have showed you, this gets stored. And this is only one transaction that I have done, right? I've just deployed the code. All of you, when all of us does, it'll take 10 or 15, whatever is the threshold, and keep all those transaction that generate one hash. And that is why it is called a blockchain. Those 10 transactions, a block is being made, and then a hash is being made over here. Right? So I think now you're able to correlate what Mani has explained us, that what is this hash coming, right? This is the hash. Now let us go back to the run command, and what I'm trying to do, I'm trying to distribute the money. So this is the first address that I've selected, that is my address. I'm saying that I want to distribute 30 ethers. Right? In the value section below this, please enter 30 and select from the drop down ether. Right? Are you guys following? Hands up or hands down? How many of you are following? All right, I think a good number. And if you see below, if you click this revenue sharing, but this button over here, you see all the variables which I have created. We have shareholders. If I click the shareholders, it says that this is the address for the 0th. We have sent 3 addresses here. At the 0th number, this is the address. Right? We can change these numbers over here. We can see whatever address we want. Number of shareholders, if I click, it shows 3. Yes, we have put 3 addresses, so we have 3 shareholders. If you click creator, it shows that I am the creator, 0xCA. If you see on the account top level, first address is mine. Now blockchain has recorded that I have created a smart contract. Now it cannot be altered, right? You have creator here, and then you have a kill, and these are the 2 functions which we made, if you remember, kill and share revenue. Share revenue is something which will share the revenue, and kill is which will kill the contract. We will not press the kill button, please don't do that, right? We'll use the share revenue function. So we have entered 30 Ethereum over here, and I'm saying go ahead and share the revenue. Now let's see if something has happened. So if you see here, my account is debited by another 30. Right now it is 69. I have not used the second address. The third, all of these get 10 each gets credited into their account. Right? So on the UI, it seems like, okay, this is a standard thing that we have been doing, but the real crux is in the blockchain logs that are being created here. If I open the log here again, so it again records that, right? It says then who has sent the money, to whom it has been sent, then again a hash has been built out, and that hash records the transaction. So what will happen in future if we want, now what has happened because of this hash getting created, this hash is registered on the blockchain. Now if I want to come back and say, yaar maine ko 30 nahi diye the, okay, you guys are happy that I have sent 30, but what I want, I'm an unscrupulous person, I want to say, nahi yaar, mujhe aisa nahi karna. उन लोगों को तो 10 each मिल गए, they are never going to check again, they're going to forget it. मैं ये transaction reverse कर देता हूँ अपने end पे, right? So that 30 gets credited back to me, and their logs will still say 110 because they will rely on the log. But there's no way you can do that, because that will be another transaction, and you will have to pay for that transaction, number 1, that gets deducted from your account. Number 2, the hash will never be the same. So what your friends who are the receiving end, what they can do, they can just verify the hash if they want to, and they can say, hey, it's something wrong you have done. And they can keep those computers who can verify this hash, and the chain will be broken. So that is how this works. This is a small demo which we have given in the interest of time. And I hope you are able to follow this. What will happen in the real Ethereum blockchain, instead of the browser, we'll use the real EVMs, we'll use the real ethers. We'll not have this good looking or bad looking screen. We'll have ugly looking screen in which we will code on black and white, just like a command prompt. We'll code there a solidity contract. We'll deploy it and we'll test it. In case we got it wrong, we have to kill it, our money gets wasted, we'll make a new contract, then we'll deploy it again, and we'll do it again and again till the time we are done. So that will happen in the real world scenario. This is a very close proximity to how the real Ethereum blockchain works, right? So the objective was to take you through what blockchain is, what are the use cases, and then take you through the technical levels. So we are nearly done with what we wanted to show you. And I think we are running on time as well. Now I wanted to open this for your questions and answers, right? Because I know there will be a lot of things that you must be not clear about. So the house is open. Any questions, anybody?
Hi, I'm Kamal, from Smart Site Innovation. I just wanted to know that at a start you said that you will keep, you can keep the video as hash in a blockchain where it cannot be altered. But the videos can be of 200, 300 MBs. So can you keep that heavy files on a blockchain? Can blockchain work as a database?
So what happens that I don't want to keep the entire file on the blockchain, right? See, what is a digital content? A video is a digital content. I just want to get a hash out of that. So for example, I can break it into smaller chunks, right? And then I can get a hash out of it. What I store on a blockchain is a hash. Now, if you alter that content and if you send it back to me, I can verify it using the hash, number one. And also because my blockchain has already received it, I may not go back to you to verify it again. So I mean, this is the implementation. There are many different forms of implementation. I'll just give one scenario, and Mani wants to add to it.
Yeah, so just to add to what Nikhil is saying, there is a startup in Bangalore which tried doing developing a device for women's security in a car. Now what they did was, the moment you push it, there is a device which is put on the rear mirror there, which starts streaming the audio video back at the backend server. Okay. Now what is being, and this device is actually 2G, 3G, 4G LoRa compliant. So all possibilities are taken care of. So what happens is, the moment you start streaming, this audio video for next 2 to 3 minutes gets recorded on a blockchain, and at the same time it basically goes to the nearby police control room and maps the nearest PCR vans, so that message can be forwarded to a PCR van about the location of the place. And why on a blockchain? Again, it is use case dependent. What do you want to store on a blockchain? Ideally, blockchain is only supposed to store a transaction footprint, but then there can be such use cases where you would like to store the blockchain data, or data on blockchain as well, because he wants to use this data as a proof in the court of law, that the data is not tampered with, right? Because it's stored on the blockchain, so it cannot be tampered with. So depending upon a use case, you can actually store a data, or ideally only a small, a footprint, as Nikhil was talking about, a hash value, right?
Right. Any other questions? Anyone?
This might be a silly question, I'm sorry. But you said that when there are multiple miners and you can compare the hash of certain transaction, and if they are not equal, then they have been tampered with, right? If I'm wrong, please correct me.
Oh, sorry, please come again.
You said that there are multiple miners and they are storing the transactions, and if the hash do not match, then there must be a tampering, right?
No, so if you remember when Mani started introducing the slides, he said a distributed ledger.
Yeah.
Right. Now, what is a distributed ledger? It's a copy of ledger that every node can keep.
Yeah.
That node could be a miner or a non-miner, right? And it's not that we keep on every time matching those. There's no use case to match those, right? It gets stored. Everybody has a copy of it, right? Even if you can, tamper with one of the copies, but remaining of the nodes will have that copy.
Yeah.
We don't have to go and back, verify the hash again and again. So
my question was based on this thing. Now, if all the miners or all the copies are under one stakeholder, then what happens? I mean, only that stakeholder has all the copies and he's answerable to everything.
But then, so then this is not the use case of blockchain. The objective is blockchain to establish a trust, right?
Okay.
Now, if there's one person who's controlling everything, even for him also to alter the blockchain will not be easy thing, because you have to generate hashes for all the transactions that is happening, right? But what he can do is he can kill it, and he can say, I don't have anything, right? So the idea is, if you remember what Mani was showing, who will be the participants of a blockchain? This is a case of an enterprise blockchain, for example. This is one company, you can say, who can own the blockchain, right? So that company can act as one of the participants in that ecosystem, but it'll have different issuance certificate authorities. It'll have different participants. Someone will be the maintainer of the blockchain. Somebody will be who can go and double check it. Somebody who can validate it. So the idea here is that you don't have to trust on any one version of mine. So just a simple thing is, जैसे हम लोग project execute करते हैं offices में, ये होता है यार आपने ये कहा था, मैंने ये कहा था, आपने वो कहा था, राइट हम ईमेल ढूंढते हैं, ईमेल में ये लिखा मिल गया, वो लिखा मिल गया, ये नहीं था, फिर टॉप में मैंने ये ईमेल भेज दिया एंड ऑल, right? So this is just one very vague example so that you can connect to it very easily. The objective is that whatever you have said or whatever you have done, you can run it on a smart contract and it gets captured. Now in an event, when you have to investigate a fraud, right, you will not be investigating the fraud always, especially when you know कि यार blockchain है, it will be get caught, तुम fraud वैसे भी नहीं करोगे ज़्यादा, एक आधा कोई try मारेगा तो मारेगा, right? And once you try to investigate it, you will get to that version that even if you have given a set of data, this is a debug thing that you try to generate a hash again, right? And from that cryptographic hash, you have to backwork the hash, right? And then you have to say that, okay, this is tampered completely, right? And also the other thing I was talking about, the fork. Even if you duplicate the chain, you may not be able to grow that chain at the pace in which the main chain is going. Right, in certain hacks that has happened in which the chain has been duplicated, in certain areas where you're not able to capture it because of smart contract flaw, which allows the chain duplication, for example, due to some. So what has happened, if you remember, Ethereum was hacked some time back. It was not that Ethereum was hacked. The way a smart contract was deployed, that smart contract allowed some kind of, some kind of scrupulous transactions to happen on it. As a result, a second chain was also being created. Right? And that is where these authorities like Ethereum or who is owning that blockchain infrastructure. So Ethereum can own the blockchain infrastructure, but not the data to tamper with. Right? So for example, just like talk about Microsoft, right? They will sell you a SQL server. And you can say, hey, Microsoft, own the SQL server for me, maintain it, do it, whatever. But they will not own the data. Right? But if they want, they can change the data somehow. On blockchain, they will not be able to do that. And even if they do that, you'll be able to catch it. That's the idea. Right, but every technology, none of the technologies are foolproof. You get to see ways in which you try to hack it, to try to change it. But then the probability of changing and the probability of getting caught, that is what that matters. That's what makes this technology a trust-less implementation of the various trust-building agencies. Right. Any other question, guys? Yeah. Is the mic?
Hi, my name is Kunal. So, while mentioning the Hyperledger, Mani mentioned there were two things. One is the blockchain, which actually stores the hash value, and the another one was the database, the world state. So, what exactly is the use case of that?
No. For that matter, any blockchain implementation will have two data structures. One is the blockchain, and the other is the world state. So, blockchain is like having all the archives, means all that has happened in the history of an asset. Provenance, whereas the world states has the current value of who owns so it's integral part of the blockchain, these two data structures.
Okay, and even the access to the world state would also be limited as per my ACL.
Obviously, yes.
Excuse me, I have a question.
Okay, so we have clash of question. So you go ahead first.
For any transaction, there is a block which has metadata of that transaction, which is what hash you are referring to, I believe, and the data. So it's a trust-based system, and the data is shared in ledger across the network. Now, as we say that it's secure because the information is scattered and it's encrypted. And if that one piece of block is tampered, then also the complete data is secure. But how if we are if we want to check that hampered information again, checking that and reconstructing that will require a huge power from our side also.
So one thing is that this is implementation. How do you implement a blockchain? You don't have to store the data on the blockchain. You can just store the hashes, right? Number one. Now, in case you are coming to a situation where you want to validate the data that is happening, so I think if I get your question right, you are saying you validated the data and you find that's wrong, right? And then you have to come up with a corrective measure. That is where the role of these enterprise blockchain owners will come in. So even in a situation where some fraudulent activity has taken place and you have caught it, the good thing is that you will get caught. The number one thing of security is that the fear of getting caught should be there, right? And which is very high here. Right, and then a corrective measure can be taken. A separate set of team will have to sit on top of that. They cannot use the entire computational power for rest of the blocks. they will have to make a fork out of it. They'll have to make one dummy block, make that block, point to that block, and move it further. Why the hacker cannot do it? That because as soon as you create a dummy block or some other way of implementation, the owner will catch it that there's something wrong that has happened, and they'll kill it immediately.
I'm sorry, sir. Now we are running out of time. So, yeah, it's okay.
Yeah, 1 minute is okay.
My question was that when you're saying you're using cryptographic hash, so are you suggesting some particular hashing algorithm to be used there? Because there are also threats to algorithms from time to time. New algorithms are coming, new threats are emerging. So is something suggested?
So every blockchain like Ethereum and Bitcoin, they suggest the cryptographic methodology that they want to use. It could be SHA-256. If not SHA-256, it could be any other methodology that can be used, right? And these are always evolving and evolving, right? So what blockchain can do, they can suggest that this is the latest hash mechanism. Let's use this, right? But then it has to stay consistent. You cannot say that one block can use this, one miner can use that, or one transaction can use this. So all the miners have to be on the same platform.
We'll take one more question. It's a very important
Besides, just to add your point, there are hardware accelerators at the hardware level, for cryptographic accelerators at the hardware level to assist that piece. So if you talk about System Z, it specifically has a layer of hardware to assist what you're talking about. Yeah, so good question there. Can we repeat the question?
So the question is, how is blockchain and IoT related to each other? I think.
So if you remember the example of that container, right? IoT container, IC container I was talking about, right? So it's an IoT enabled container, which is actually transmitting back the temperature at all the points in time, right? Now this temperature is actually recorded on a blockchain, means nobody can fudge the temperature rating. So because otherwise the transporter can always fudge the data, right? It can manipulate the gauges and all that, which is not possible when you are actually using a IoT transmitted data getting recorded on a blockchain and so on. And there are numerous IoT implementations on blockchain intersection points.
Okay, guys, we have to cut it now here. Thank you, everyone, for your time. May I call upon the ladies in the room, today being a Women Day, to go away with a token of appreciation to the two speakers here. Ma'am, you can also please come, if you don't mind. Thank you. Please come.
Just to let you know, women today have already answered a lot of questions. So very huge class participation.
Please.
Look at the camera. That's it. That's
Thank you. The next one to Madhukar from IBM.